BioBright saves scientists hours and even days of time by automatically sending data and metadata from instruments to a central repository on the cloud. Additionally, unstructured and proprietary data from instruments can be parsed into usable formats and made easily accessible via the API. This accessibility provides the opportunity to send instrument data downstream for further analysis, either within the Dotmatics platform or to third-party applications. The intuitive BioBright interface describes the instrument fleet available to the end user in a series of banners at the top. Users can view their instruments and understand high-level parameters, such as the number of uploads per file-based instrument. Further information is provided for file-based instruments in a drop-down frame. Within this frame, users can see the folder path where the instrument file was dropped and can add additional folder paths to watch if desired. Multiple tabs allow users to view system information to understand the health of the system at a high level. Viewing and searching for files on an instrument is simple. Users can click on this option and use text-based searching. This enables them to find, preview, and download files of interest. A view to upload history can provide an understanding of how often the instrument is dropping files. This is available per day of the week and per week of the year. This can empower decision makers to review the return on investment of an instrument and better plan for purchasing decisions. BioBright can also connect to system-based instruments. Here we show a connection to Waters Empower chromatography data systems. Users can select a project to view injections and view numeric results for each injection. Viewing chromatographic peaks can be performed in the dashboard section of the software. The Files menu houses several useful features for file-based instruments. Users can view their instrument, select the checkboxes, and download multiple files at a time. Doing so will provide a zip file of the downloads available in the Downloads window. Users can also view version histories. The clock icon indicates that multiple copies of this file have been uploaded. Right-clicking and selecting Info will provide a pop-up window in which a user can preview and download multiple copies for each version. This ensures that the older versions are not accidentally overwritten with new file uploads. Users can also conduct searches across the whole fleet of instruments. This is especially effective as a time saver for scientists performing a multitude of experiments on disparate systems. The ability to quickly search through this cloud repository and download relevant data eliminates the arduous task of collecting content off of many different instruments. Dashboards show the power of BioBright's ingestion and processing capabilities. Information from instruments can be displayed in interactive visualizations to allow the end user to view multiple variables from multiple instruments at a time. For example, here we see an amber system. This represents a bioreactor system. We can choose as many bioreactors as we wish to aggregate information from. And we can choose multiple variables to display across all of the different bioreactors. Here we are looking at carbon dioxide evolution rate and dissolved oxygen. This mustache plot that is generated will provide an easy-to-read comparison of the different bioreactors for the different selected variables. Here you can see on the y-axis these two different variables selected, and all of the bioreactors are displayed on the x-axis. End users can use the time selector down below to hone in on their data for the selected time. A scientist may use this visualization to answer questions about the health of the cells in the bioreactors and the performance of the bioreactors themselves. These mass spec dashboards provide further examples of the quality checks a scientist can perform on the data before sending it off to further analysis. Here we see the ability to pull back historic data for these different projects. This allows a scientist to understand retention time of standards over time. A scientist may use this line graph to make decisions such as, should I change my column, or to diagnose other issues with the standard. As with the other visualizations, the data behind this visualization can be exported, or this visualization can be saved as an image file. BioBright can ingest plate-based data and can display images associated with the plates and the exact orientation of the plate run. Here is a demonstration of a 96 well plate. A user can select any of the images here and use the built-in magnifying glass to explore the image further. This particular plate has 54 associated time points. And for each time point, there are 3 available microscope views. You can see the power of the system's image handling ability by the quick load time of the more than 15,000 images associated with this plate. This 384 well plate similarly captures multiple images per well. Specifically here we have 5 images for blue and 5 for green wavelength fluorescence. Once again, users can click on each image to view a magnification of the cells in each well. A clipped setting processes the fluorescence and highlights overstaining. This quality check may help a scientist validate their fluorescent stain. Images can be downloaded as a TIFF file, and additionally, the underlying data can be downloaded as a CSV. Of course, this information can also be exported or sent for further analysis using the API. We can push this data to the Dotmatics ELN as well. Documentation to the API is available in the top right corner. Our open API makes the data brought into the BioBright cloud accessible to downstream applications. The API available is the same API we use to send data to the Dotmatics ELN. Within the Dotmatics ELN, users can access all the instruments available in the BioBright user interface by clicking on the BioBright light bulb icon. Here we can pull in data from any of these connected instruments by finding the instrument and the file we desire, right-clicking on the file, and clicking Attach to ELN. Here we see this attached screenshot. Now this image is linked to the experiment I am currently running. We can also leverage processing scripts to pull in files from the BioBright system over to the .matix ELN. In attaching this to my experiment, I can use a processing script to load content that is available in this Excel document to my analysis section here. By running the processing script, I not only am now making this available for searching in the .matix platform, but I am also performing a kickoff to my analysis. From end to end, we have automatically swept information off of an instrument, brought it over to the ELN, and analyzed that content, saving the scientist hours of time locating, extracting, and wrangling that data.